All right, here we are on Unit 6, Plane Geometry of our ACT prep, and we are on day 5 today. We're going to talk about right triangles. So the first thing we're talking about is in a right triangle, the two sides of a right triangle that meet at the right angle are called the legs. The third side, which is always across from the 90-degree angle, is called the hypotenuse, also known as a squared plus b squared equals c squared, which is fine as long as everybody labels their triangles a, b, c. If they don't, you know that a and b represent, really, the formula should say leg squared plus leg squared equals hypotenuse squared. That alleviates, if they don't label their triangle ABC, of not having to use ABC. Okay, but that is the Pythagorean theorem. The leg squared plus the other leg squared has to equal the hypotenuse squared. Okay, so one says the lengths of the legs of a right triangle are 3 and 4. I always like to draw a picture. So they're telling me the legs, which are the two sides that make the 90-degree angle, are 3 and 4. What is the length of the hypotenuse? So they want to know h. So I say leg squared plus leg squared equals hypotenuse squared. 3 squared is 9, 4 squared is 16, 9 and 16 is 25. To kill the square now, I'm going to take the square root, which gives me h equals plus or minus 5. But a negative length doesn't make any sense, so we ignore the negative 1, and my hypotenuse has to be 5. That's actually a very famous right triangle, the 3, 4, 5 right triangle. 2, the length of one leg of a right triangle is 4. So one of the legs is 4, and it says the length of the hypotenuse is the square root of 65. How long is the other leg? So I would have leg squared plus my other leg squared equals my hypotenuse squared. So when I simplify this, I'm trying to get x alone, so this is 16 plus x squared. When you square a square root, they cancel, so that's just going to be 65. Now I'm trying to get x alone, so I'm going to minus 16 minus 16. I have x squared equals 49. Kill the square by taking the square root, and I get x equals plus or minus 7. But again, we ignore the negative 1 because you can't have a negative length. Alrighty? Whole numbers that satisfy the Pythagorean theorem are called Pythagorean triples. The most famous Pythagorean triple is 3, 4, 5. You should memorize it. Anytime you see a right triangle that has two legs that are 3 and 4, the hypotenuse has to be 5. The multiples of Pythagorean triples are also Pythagorean triples. So here are the first 4 triples along with the first 3 multiples of the 3, 4, 5 triple. So if you have a triangle that has legs of 3, 4, and a hypotenuse of 5, if you double those, 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. There's the next one. The next multiple would be multiplying your beginning ones by 3. 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. And then the fourth would be 3 times 4 is 12, 4 times 4 is 16, 5 times 4 is 20. So we could do that with the other triples, okay, the next set of triples. Well, to get the next ones, 5 times 2 would be 10, times 3 would be 15, times 4 would be 20. 12 times 2 would be 24, times 3 would be 36, times 4 would be 48. 13 times 2 would be 26, times 3 would be 39, times 4 would be 52. And you can do that for the 7, 4, 25. 7 times 2 would be 14, times 3 is 21, times 4 is 28. 24 times 2 is 48, times 3 is 72, times 4 is 96. 25 times 2 is 50, times 3 is 75, times 4 is 100. And 8 times 2 is 16, times 3 is 24, times 4 is 32. 15 times 2 is 30, times 3 is 45, times 4 is 60. 17 times 2 is 34, times 3 is 51, times 4 is 68. And you could just keep doing this all day long. Okay? But those are Pythagorean triples. Memorize this one for sure, because this is a pretty famous one. The other ones, I've never really seen them anywhere, to be honest with you. The 3, 4, 5 is a pretty famous one. Okay, when you have an isosceles right triangle, it says both legs of an isosceles right triangle are the same length. So anytime you have isosceles right triangle, that means two sides are equal, which means the two base angles are equal. Okay, so an isosceles right triangle is a 45, 45, 90 triangle. And the interesting thing is the relationship between the legs. The length, first of all, the legs have to be the same. So if you know one leg, you know the other leg. Leg 1 and leg 2 have to be the same. And then what it says is the length of the hypotenuse is the square root of 2 times the length of a leg. So if I'm trying to find the hypotenuse, I just take the length of one of my legs, it doesn't matter which one, and multiply it by the square root of 2. Okay, so in an isosceles right triangle, you can quickly find the lengths of all the sides once you know the length of any one of the sides. Alright, so, oops, skipped a page. 1 says the length of a leg of an isosceles right triangle, which means it's a 45, 45, 90, which means these sides have to be the same, and the hypotenuse has to be the length times the square root of 2, the length of the leg. So it says the length of one of the legs of an isosceles right triangle is 5. So if the one of the leg is 5, the other leg is 5, and the hypotenuse would be 5 square roots of 2. Okay. 2, it says in an isosceles right triangle, the length of the hypotenuse is 14. Well, I know that these have to be equal, and I also know that the hypotenuse is the length of my leg times the square root of 2. So I can say 14 equals L square root of 2 because I know what the hypotenuse is. Okay? So now to figure out what the leg is, all I got to do is divide by the square root of 2. And that's the length of my leg. You don't leave an answer with a radical in the denominator, so I have to rationalize that. So I'm going to multiply the top and the bottom by the square root of 2. That gives me 14 square roots of 2 over 2 equals the length of my leg. 2 goes into 14 7 times, so the length of my leg is 7 square roots of 2. So each leg is 7 square roots of 2, and this leg is 7 square roots of 2. And the hypotenuse is 14. Okay? Just remember, you should never leave a radical in the denominator. What we just did, if you remember from lessons past, is rationalize the denominator. You cannot have radicals in your denominator. Okay, the next most famous right triangle is a 30, 60, 90 triangle. In this type of triangle, okay, when you have a 30 and a 60 and a 90, what you always have to remember is your shortest side will be next to the 60, and your longest side will be next to your 30. So just remember, it's kind of backwards. You'd think 60 is bigger, it'd be the bigger side, but it's not. 60 is bigger, which makes it the smaller side. 30 is smaller, which makes it the longer side. Okay? And the relationship is, it says the hypotenuse is twice the length of the shorter leg. So I'm going to put, let's use S for short leg. Okay? And the longer leg, so let's call that L for longer leg, is the square root of 3 times the shorter leg. So I would take the shorter leg times the square root of 3. So you need to memorize these two relationships for a 30, 60, 90 triangle. Okay? Alright, so it says the longer leg of a 30, 60, 90 triangle is 21. So I'm going to draw mine here. This is 60. This is 30, this is 90, so this is the short leg, this is the long leg, and this is the hypotenuse. And it says my longer leg is 21, and they want the length of the hypotenuse. Well, if I get my little handy-dandy formulas, my hypotenuse is 2 times the shorter leg, and my longer leg is my shorter leg times the square root of 3. They want the hypotenuse. So my hypotenuse is going to be 2 times the shorter leg. Oh, poop, I don't know the shorter leg. So I'm going to have to figure that out. Well, I know that my longer leg is my shorter leg times the square root of 3. So I can replace L with 21 because I know the length of my longer leg, and that will be my shorter leg times the square root of 3. So to figure out what S is, I need to divide by the square root of 3. And my shorter leg is 21 over the square root of 3, which I need to rationalize. So I'm going to multiply by the square root of 3, square root of 3. That gives me 21 square roots of 3 over 3 equals s. Simplify. 3 goes into 21 7 times, so my shorter leg is 7 square roots of 3. Which they don't want to know, but I need to know to find the hypotenuse. So now I can say that my hypotenuse is equal to 2 times the shorter leg, which is 7 square roots of 3, which makes my hypotenuse 14 square roots of 3. Okay? Yep. Okay? Just checking. Alright, so you tried this one. Hit pause. Come back when you're ready. And hopefully you got 8. It says, what is the length of AB, which is a leg, of the triangle shown below? Well, this would be Pythagorean theorem. It's not a 45, 45, 90 or a 30, 60, 90. If it is, you can't assume that. If it is, they have to tell you. So if it's not a special, I'm just going to do straight up Pythagorean theorem, which is leg squared plus leg squared equals my hypotenuse squared. That's L squared plus 25. Again, the square kills the square root, and I get an 89. So subtract 25, subtract 25, I get x squared equal, or L squared, sorry. L squared equals 64. Square root and L equals plus or minus 8, but we only take the positive one because lengths can't be negative. Okay? Alright, some practice problems. 1 says, what are the measures of the angles in an isosceles right triangle? They are, in an isosceles right, the angles are 45 degrees, 45 degrees, and 90 degrees. 2, use the Pythagorean theorem to find the measure of the hypotenuse. Well, we have leg squared plus leg squared equals hypotenuse squared. That's 64 plus 36 equals h squared. That's 100. Square root, and I get h equals 10. My hypotenuse would be 10. Okay, 3, what is the length of the missing leg? Well, again, leg squared plus leg squared equals hypotenuse squared. That's going to give me 81 plus a squared, cancels out, equals 117. Subtract 81. I get a squared equals 36, square root, and I get a equals 6. Okay, this is an isosceles right triangle, which means the legs have to be equal. So that means B equals 4, because this leg is 4, that leg has to be 4. And in an isosceles right triangle, you have to say that the hypotenuse is the leg times the square root of 2. So my hypotenuse is going to be 4 square roots of 2. And my other leg was 4. Okay? Number 5, it says this is a 30-60. So remember, this is the short side, this is the long side. And we have the hypotenuse is equal to 2 times the shorter side. And my longer leg is equal to my shorter side times the square root of 3. So if I want to find A, I say the long leg. Wait, I got to find the short leg first because my formulas are in short leg. So my hypotenuse, which is 16, is going to be 2 times my shorter leg, which I don't know, they called it B. So to figure B out, then I'm going to divide by 2, and I get my short leg equals 8. So then to figure out my long leg is my short leg times the square root of 3, which makes my long leg equal to 8 square roots of 3. Okay, Pythagorean theorem to find the length of the hypotenuse is leg squared plus leg squared equals hypotenuse squared. That's 25 plus 36 equals n squared. That's 61 equals n squared. Square root, square root. 61 is prime. You can't break it down. So we could go decimal, but unless they ask for a decimal answer, you leave it radical, which would just make my hypotenuse the square root of 61. Okay, in 7, we want to find the lengths of the missing legs. So in 7, I have leg squared plus leg squared equals hypotenuse squared. That'd be 16 plus b squared equals 41. Take away 16, I get b squared equals 25. Square root, and I get b equals 5. On 8, I'm going to have a squared plus 4 squared equals 5 squared. That's a squared plus 16 equals 25. Subtract 16, I get a squared equals 9. Square root, and I get a equals 3. Which actually, if I would have been paying attention, when you see a 4 and a 5, remember that your most famous Pythagorean triple is a 3, 4, 5 right triangle. And I should have noticed the 4 and the 5, and I wouldn't have needed to do the math because I knew that the other side had to be 3. Alright. Number 9, the figure below is an isosceles right triangle, which means my legs are equal. So B has to equal my other leg, which is 3. And remember, in an isosceles right triangle, your hypotenuse equals any leg times the square root of 2, so my hypotenuse is going to be leg square roots of 2. Okay? And on 10, we've got a 30, 60, 90, so remember this is the short side next to 60, this is the long side next to 30. And my formulas are the hypotenuse is 2 times the short leg, and my long leg is my short leg times the square root of 3. So my hypotenuse is equal to 2 times the short, which is 6. So my hypotenuse is 12. My long leg is my short leg, which is 6, times the square root of 3. So my long leg is 6 square roots of 3. Okay? You try this one, hit pause, come back when you're ready. Hopefully you got C. So it says, what is the length of the hypotenuse of the triangle shown below? Well, leg squared plus leg squared equals hypotenuse squared. So that's 25 plus 144 equals hypotenuse squared, which is 169 equals hypotenuse squared, square root, and I get h equals 13. Okay, try this one, hit pause, come back when you're ready. Hopefully you got F. Okay, it says what is the product of B and H in the triangle shown. So first I have to find B and H, and then I have to multiply them together. It's a 30, 60, 90. So this is the long side next to 30, short side next to 60. And my formulas are that my hypotenuse equals 2 times the short leg, and my long leg equals my short leg times the square root of 3. So my hypotenuse equals 2 times 6, which gives me h equals 12. And then I get my long leg is my short leg times the square root of 3. So there's my long leg. So they want me to multiply these two together, which would be 12 times 6 square roots of 3, which is 72 square roots of 3. Okay. Alright, try this one, hit pause, come back when you're ready. And hopefully you got T. What is the sum of A and H in the figure shown below? Well, because it's these two little ticky marks, that means those sides are equal, which means I have a 45, 45, 90 right triangle. And if I have a 45, 45, 90 right triangle, my hypotenuse is either leg times the square root of 2. Well, since this leg is 10, that makes A is 10, and that makes my hypotenuse 10 square roots of 2. So it wants me to sum them, which means I need to add them, which would give me 10 plus 10 square roots of 2. And I can't combine them because 10 is not a radical and 10 square roots of 2 is. Okay? Try this one, hit pause, come back when you're ready. And hopefully you got G. Alright, the base of a ladder is placed 10 feet from a house. So you've got this house here. 10 feet out, there's a ladder. that leans up against the top of the house. Okay, and it says the ladder touches the house 14 feet above the ground. So it touches up here, which means 14 feet above the ground makes that distance 14. This distance is 10. And it says if the house creates a 90-degree angle with the ground, how long is the ladder? So they're asking you for the hypotenuse. So I have leg squared plus leg squared equals hypotenuse squared. That's 100. That's 196. Which gives me 296, square root, and again, my answers are in decimals, so I have 17.20465053, blah, 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 blah. But they want me to round to the nearest tenth. There's my tenths place. 0 isn't going to bump it up, so the length to the nearest tenth would be 17.2. Okay, try this one. Hit pause. Come back when you're ready. And hopefully you got B. So we have a 30, 60, 90, which makes the short side next to 60, the long side next to 30. What is the sum of the lengths of sides AB and BC, which is the short leg and the long leg? Well, my hypotenuse is 2 times the short leg, and my long leg is my short leg times the square root of 3. So my hypotenuse, which is 8, has to be 2 times my short side. So my short side has to be 4. My long side then has to be 4 square roots of 3. And if I add my short side plus my long side, I have 4 plus 4 square roots of 3. B. Okay? And that finishes day 5 on our right triangles. And I will see you next time for day 6.